To meet everyone. Maybe I could learn everyone's name.
Sure.
My name is Richard.
I'm Eliane.
Eliane?
Yes.
Miriam?
Marion?
Yeah.
Pleased to meet you. Marion? Eliane?
And I'm Isla?
Isla?
Yes.
Don't go too fast now. I gotta remember all these things. Isla, and Miriam. And say it again.
Eliane.
Eliane.
Right.
And
Okay.
I am Jacob.
Jacob?
Yep.
Okay, pleased to meet you. Hey. So we are few, and we can go whichever ways you guys are interested in. And I got a bunch of slides, but there's only a few that I really want to present for sure.
Well, I sort of have the impression
Yeah?
that we've a little bit made history many times when you've talked here. So anything that you think would be more likely to be making history is of more interest than things that aren't going to make history. So
Well, I think it is a historical time, and I'm sure you're all
Yeah.
young people, and you're only familiar with your own time in some sense, and you think it's just normal. But I don't think this is a normal time that we're in. I think it's a time when, well, massively increasing computation is available to everybody and to our companies and people who make products. And this is really the only time like this. I mean, in some sense, 100, 200 years ago, there was the Industrial Revolution. They discovered machines that, like steam powered and could do physical work for people. No, but that really took a long time. Whereas now, with computation becoming much more plentiful, it happens, well, the standard thing is to say every 18 months, the computer power available for the same amount of money doubles. Twice as much. And so that means our phones are working better each year, and our laptops are more capable, but also, everyone making products, the network. Yeah, so you guys are probably citizens of the network. Rather, and the network will compete for your allegiances, just the way the nation states do, just like Canada does, and all the other countries. But your allegiance may end up being more to your fellow digitally enabled people enabled by the network, by their phones. So this is the thing that's happening now. And it's my first take-home message, that we are living in the time of exponentially accelerating computation. It's really dramatic if you look at it from a little bit of a distance. I've been doing this for 45 years. So I can see it. Exponentially accelerating. It's kind of slow. It used to take 2 years for computational power to double. Now, I've been saying it takes 18 months, and some of my colleagues are saying it's just a year for things to double. But, it takes even if it takes a year, it takes a whole year before your computer is twice as big, and it seems slow, right? You say, I've got all these extra videos on the computer, and I have to buy an extra disk or something. It's a problem. But really, if that happens year after year, doubling every year in 18 months, and that happens for decades, it's on the order of 100 years now that it's been going up. And it's every expectation that it will continue, if not become even a little faster. So this is really special. So the name for it, let's just hold off on the next bullet point, although I'm really excited about it most of all. But it's this trend. This is the trend. This is Moore's law. Computer power per dollar increasing exponentially. No end in sight. And this is some data from Kurzweil AI. So here we have years, back in 1900. up to near now. And up on the other axis, we have computer power per dollar. And so these are actually individual computers, like, you know, the Mac, the original Mac in 1984 would be one of these points. And then you can plot out other laptops and supercomputers. Supercomputers are more expensive, so, but they may get more per dollar, more computation per dollar. Okay, so computer per dollar is on this axis, but critically, this axis is a logarithmic scale. This is a linear scale. Every one of these marks is 10 years, right? Here, every one of these marks, the big marks, from here to here to here, is 10 powers of 10. Okay, so that's a factor of 100,000. Okay? And so, because it's a log scale like this, if it was a straight line, it would be really an exponential increase, a continued exponential increase. So as I said, it seems to be slightly super exponential. But that curve up is so slow, we can consider it like we're here, we're at essentially a straight line. Okay, so what are we looking at? We're looking at, in some sense, exponential, well, it is exponential increase, at least exponential increase, computer power per dollar. And an exponential, it's really the way to think about it, it's an explosion. It's an explosion because every year it gets a bit bigger, and then next year gets bigger by the same percentage. And it keeps doubling every 2 years. So it's really, almost literally, what we mean by an explosion. Okay, so I know you've talked about the singularity. You've talked about singularity? One more time. Marianne or Marianne?
Either is fine.
Good enough? L-E-N? And Jacob and Isla? Oh, great. What was I going to say? Oh yeah, I was going to say, you guys have talked about the singularity, right? But never, maybe it's never properly defined. What have you been taught? What different views have you gotten of the singularity?
The combination of human with technology.
Yeah, so you're saying it's a reference to the increasing role of technology in our lives. Is it an event? Is it a time? Is it a moment in time? What is the moment in time? It's got to be something, the time when something happens. What's the...
It's an hypothetical future. So
Excuse me?
it's hypothetical future, so it doesn't have a specific time.
Sometime in the future, so when...
Depends on how fast technology advances.
No, when it happens is uncertain.
Okay.
But what is it?
Um, so it's a situation where we have a relationship between humanity and technology that is such
So maybe it's the time when the technological beings and the human beings are at some comparable level.
Yeah.
I think that's what you're thinking. Good. Any other notions you want us to bring up? Yeah, so I think one thing I'm trying to say is we get to decide what it is. You could decide it's the moment when AI overcomes human abilities, but human abilities will continue to increase, right? We'll get smarter when we have better education, when we have better tools and better phones. And we will continue to augment ourselves. We will, we augment ourselves with our phones now, but we will eventually be augmented by implanting things in our minds and by direct, stronger connections between us and our machines. Yeah, we can decide what the singularity is. But so what I always learned was singularity. So there's this doubling every year or two, and you can't really totally anticipate what's going to happen. And the point of a course like this is to think about what's going to happen. But we can't, because, well, so many amazing things happen. Machines will get more powerful, people will change, and maybe the machines will compete, maybe they'll be our offspring, maybe they'll be our descendants. It's hard to see the future after a certain point. And so that, for me, has always been one of the core meanings of singularity. It's the point, it's the horizon by which you can't see further. And when you try to predict what will happen. Okay, but when you get there, when you get to that point that you can't see past now, when you get there, you'll be able to see past it, because you'll be there. You'll be able to see a little bit further. So in the sense, if it's the sense of the point which you can't see past, then it will recede, and it will forever recede. You won't actually get there. Okay? Another part of the sense is it's an explosion. Anyway, so what I want to lead you to is the idea that maybe we are in that singularity. Because this doubling is happening so regularly, there's a point we can't see past. Maybe it's 2040, we can't see past what will happen now. What will happen in 2040? We can't see past that. But when we get to 2040, we'll have an idea. And so the explosion, maybe this is the explosion, and we are right in the middle of it. And it's a slow explosion. It will always be slow. It takes a whole other year to double. The double will be a bigger in terms of absolute amounts that you're adding, but it will still just be a doubling. I think it will always seem slow. I think the thing that is the singularity is the explosion of computation and intelligence. We are in the midst of it. And so this is beautiful because it means there's not this future thing that we're going to encounter. We can encounter it right now. We are encountering it. It'll just be more, it'll be more transformation, more doubling, more increases, more change. And it'll feel much like it does now. So I think this is the story of our time. Exponentially increasing computation, and it will be the story for the foreseeable future. Anything that uses computation becomes 10 times more valuable every 5 years. 10 times more valuable every 5 years. So you know this. You're working in different fields. Like what fields are you working in?
Psychology.
Say again?
Psychology.
You're in technology.
Psychology, sorry.
Psychology. Okay, I was originally trained in psychology myself. I like that. And
Neuroscience.
neuroscience, cool.
Education.
Education.
Biomedical engineering.
Say again?
Biomedical engineering.
Biomedical engineering. So I think you know in your areas that computer power is having more of an effect. Like in neuroscience, they can measure more neurons at the same time and record it. And in biomedicine, they can operate now with robots, and they can manage the data and search through the data and find diseases. And by the way, what did you say was your area again?
I'm in education.
You're in education, so you know that there's a big thing now to try to make computer tutors, like all these large language models, to use those to give an individual tutor for each student. And that's perhaps, maybe is the biggest impact of computer power on education, would you say, or would you say something else?
I would say so,
Yeah,
yeah.
yeah. But it's true, I think of all the sciences, you know, if you look at physics, the things that they can simulate on a computer are much more important. Or biology with genetics, psychology, all that you can do with simulations to model mental processes. It's a big deal. All the sciences have changed. And all of our just ordinary lives, because we have computers, we have laptops we can use individually, we can analyze data, we can communicate to people around the world. We're all transformed, and we will continue to be. Well, sort of the theme is computation and intelligence. Now, today we have the intelligent things are people, and they're really almost only people. We have systems that use a lot of computation, like large language models, or like AlphaFold. You guys know, did you guys, have you covered AlphaFold? Yeah?
Yep.
Figure out all the proteins in the, that are known to humanity, how they fold up in three-dimensional space, and how this changes all the research possibilities. But that's not intelligence. I mean, look, I'll work towards a real definition, but I would just like to urge you to think, maybe that's not intelligence. I mean, it's called AI, but I think the way we use the word AI nowadays, they just, if something uses a lot of computation, they call it AI. But I think we should mean more than that when we say intelligence. I think, yeah, people are intelligent. AlphaFold's non-intelligent. Yeah, I want to distinguish these two, because like now so what about my take-home message here was, we're living in this time of exponentially accelerating computation, and we're entering the time of exponentially accelerating intelligence. You're just entering that. And as both of these changes, the greatest will lead, both of these changes will lead to changes in what we do and transformation of ourselves. The greatest ones will come from the intelligence, accelerating intelligence, because we're really making things that are comparable to ourselves, but without biological replication. And then we will be becoming the things that we are creating will be becoming even more intelligent than current humans are, current people are. So these two transformations, increasing computation, increasing intelligence, are closely related, sure, but and that way, because of this, they're easily confused. And what I want to propose to you, the difference is that intelligence is computation plus some notion of goal or purpose or agency. So those are the general points I'm leading to. Okay. Okay, so computational power of machines substitute for the computational power of people. That's sort of what's happening. We use people in various jobs that people do. We use them for their perception and motor control, prediction abilities, search abilities, optimization abilities. And until now, people have been our cheapest source of computation in the sense, but now machines are in some cases providing greater and cheaper computation. And so here are some of the successes over the last maybe 12 years. The oldest one is when best human plays in Jeopardy, and not long after that, in 2012, neural networks really transformed how we do speech recognition, vision, natural language processing. Large language models in particular, you probably use them more than I do, but they do all kinds of, they can appear to speak and understand. And the generative methods for generating pictures as well. Very impressive. So all those things are impressive. I would not count any of them as intelligence, though. I would count as intelligence when they used deep reinforcement methods to play Atari and Go and all the other games. And in these cases, the AI had a goal. The intelligent system, the computational system had a goal, which was to win the games, and it adjusted its behavior in order to continue winning. So that's what I want to say is the essence of intelligence, is being able to pursue a goal. And when you use like the large language models, they may appear to have a goal, but it's really literally true that they don't have a goal. They're just mimicking people. They're saying the same things people would say or have said in similar situations. They have no sense of trying to, certainly they're not trying to manipulate you, because they don't have any goal, except for perhaps their designers could have had a goal. The designers, the people that were designing it would be trying to manipulate you, but the machine itself doesn't have a goal. Okay, so maybe it is time. Maybe it is time for a definition. Okay, so the definition, here's some definitions of intelligence. Well, it's not, first one is not really a definition, maybe it's a fact. It's claimed to be the most powerful phenomenon in the universe that occurs wild. And I'd just like you to this idea. Is this crazy? The most powerful phenomenon in the universe. It's claimed to be the intelligence, and we people are the primary model of intelligence. We're sort of saying that we people and our intelligence is the most powerful thing in the universe. More powerful than, supernovas or dark energy. Does that make any sense to you guys? Yeah? Does to you, Ayla?
I mean, yeah, I would agree.
In what sense? Is
I mean, everything makes up intelligence. If we talk about black magic, there's intelligence in that.
Yeah.
Everything makes up intelligence, so it makes sense that it's most powerful.
So, one thing, I like to think, if it's more powerful than a supernova, this huge explosion in the sky, I think it's saying that people or intelligences, which maybe came from people, will someday be moving the stars around. We will, over time, we've only been here for a few, maybe 100,000 years for people like that. If you give us 1 billion years, we could become quite powerful physically over time. And we could end up being the force that moves the stars around and rearranges the universe, the atoms in the universe to our liking as a group. So when we think that way, we're so to think in a little bit arrogant way, right? We think we, intelligence, would be so powerful, would be the most powerful in the universe. Well, we're saying that intelligence is quite a thing. And so I think we should by the word intelligence is just a word that we can mean by it anything we want to, but we should mean by it something that could be this powerful. Okay, and what I'm proposing is that it's goals. It's the ability to have purpose. That's the powerful thing, and that's the powerful phenomenon. The phenomenon, if you look around the world, you'll see there will be things like people and animals, and maybe even plants, that appear to have goals, that are well thought of in terms of goals. And that is the phenomenon that we observe. So William James, Marianne will know, he's the original psychologist. This textbook was 1890, and he was the first one to talk about strategic goals. When he talked about mind, he didn't use the word intelligence, he used the word mind. He said mind is attaining, the hallmark of mind is attaining consistent ends by variable means. So it means you change what you do to get what you want. The essence of having a goal is to vary what you do to get what you want. Yeah, and if we go to the AI researchers, the most famous one of the top ones of all time, John McCarthy, he finally defined, offered a definition of intelligence as the computational part of the ability to achieve goals. So he's thinking the way I am. I probably learned from him, actually. But it's the computational part of the ability to achieve goals. And I might say, myself, I might say the computational part of the ability to predict and control your environment, predict and control your data stream. Because I'm sort of a computer scientist, and I think in terms of data going back and forth between the world, you try to understand it and control it and predict it. Okay, so nevertheless, so those are the kind of definitions that I like, but I want to just talk a little bit, just want to be explicit about people are using the word differently nowadays. They often take intelligence as mimicking people. As in, AI seeks to reproduce behavior that we would call intelligent if it was done by people, which is the kind of thing that AI textbooks often say. And I'm sure you guys have covered the Turing test, yes? Yeah, well, the Turing test is about mimicking, it's about a computer and a person are put in sealed rooms, and you talk to them by text chatting, and you try to figure out which one's the person, which one's the machine. And so that Turing test is, can you make the machine behave like a person and mimic a person? So this is a prominent meaning. I'm going to say I'm going to discourage you from it, but I have to recognize it is widely used. And it's machine learning, supervised learning. The task is to label, say, pictures the same as a person would label it. And ChatGPT is tasked to generate text like a person. And so sometimes we say these things are intelligent, but notice none of these things are referencing to goals. We're just saying behaving like a person, mimicking a person. Again, so just to cut to the chase, my whole point is to say this is an insufficient meaning of intelligence. Because if you're just able to mimic people, you're not going to become the most powerful phenomenon in the universe. You're going to be able to fool people into thinking you're a person, but you're not going to move the stars around, and you're not going to become a really powerful force in the universe. People may, but something that imitates a person, it's not going to be powerful in that way. You have to get at the real thing that people are doing that makes the people powerful and their intelligence powerful. Okay, well, these are our two definitions of intelligence. It could be mimicking people, or it could be as achieving goals, computational part of the ability to achieve goals. And so we just put those on the table, talk about which one's better. And now, I've sort of given up on changing the way people use words. I'm facing the fact that the world, is going to call ChatGPT AI. It's a shame, I think. Maybe that's why we have this other term, artificial general intelligence, AGI, because we've got to distinguish it. But it's just like corruption of language. And you should keep in your mind that there are these two things, mimicking people, whereas a system that has agency can choose its actions and is trying to act to achieve goals. Okay, maybe now I should jump to something that moves around. I do have one sort of video thing in here somewhere. So this picture, this is a very simple system, but it does have agency. And so this is a maze. There's a start location, there's a goal location. And our little agent is this square. If I touch this, it will start moving around. Here it's moving around because it has actions. It can go take a step to the right or to the left, or up or down. And of course, it takes a step that runs into an obstacle, and it doesn't move. But it does move. And when it finally stumbles upon the goal, it then learns a path to the goal. And what you're seeing in these colors and in these arrows, this is showing what's going on in the agent's head. The real world doesn't turn green, but green means it thinks that's a good state, because it's close to the goal. And the arrows indicate how good it thinks each one of its actions, each one of its 4 actions are. And so, for example, this cell, it thinks each one of the 4 actions have various values, and with this along the arrowhead is one it thinks is best. Now, the goal has been removed from where it used to be, placed in a new location. The agent goes back where it used to be and trying to attain the goal, searching for it. And so its perception of how valuable it thinks those states is gradually going down. And then when it does stumble on the goal, the value of those states near the goal come up. Okay? Have the idea? And it's important to note that these states, these grid cells, are just unrelated to each other. They don't really have a spatial location. They're just, so for example, if it was here, you might notice that here it's in state 14, and if it goes action number 2, it ends up in state 34. That's how its life is. It's just numbered state to numbered state as a consequence of the numbered action. Okay? Well, this system learns a model, so even though it's here, when it finally discovers the goal, these states will like it hasn't been here yet, but it knows that it's good to go up because it's doing a form of reasoning. It says, if I was there and I took the action that we would call up, it says I'll end up in this state, which I know is a good state. It's a side state, but it will go up when it gets here. So it's doing the primitive things of, it has a model of trial by trial and error, like instrumental learning in psychology, and it's also making a model of the world and doing reasoning. What we might call reasoning, which is, it's using the model to figure out in advance what the right actions to do are. So this system, I'm comfortable saying it has a primitive kind of intelligence, it has the ability, it has a goal, it has the ability to achieve its goals by interacting and learning. And this thing does run in real time. You can just interact with it, play this mouse, interact with it, and see what it does. It's kind of fun to play with. So, yeah, I'm interested in various obstacles. So, now I want you to ask yourselves, there's the little guy. Do you feel sorry for him at all? You do, because you get the sense that he's striving to do something and the world has been arranged so he can't possibly succeed. That's so I think that's actually kind of a deep thing, that we impute agency to things that behave in a certain way. And that's reality. That's not an illusion. Unless you want to say all of reality is an illusion. It's a perception or an appearance that is useful for us to understand systems. Okay, so there's a system that has a goal. So when I say ChatGPT doesn't have a goal, I mean the exact same situation. It will always do the same thing. It doesn't pay any attention to what you do in terms of influencing what it does. Be clear about that. Yeah. Yeah, so it's often described as a learning system. Neural networks are often described as learning systems. But when their normal way of using learning neural networks today, they are all learned in advance of being used. So that they receive a big training set, and they kind of crawl all over the training set and extract information from it. They learn from the training set. Then once they're put out in the world, they no longer learn. They no longer learn. ChatGPT no longer learns. AlphaFold was built with great effort, but it, once it goes out in the world, it's no longer learns. So that's a shame. And I think you've seen in this example how it's maybe important what we mean by intelligence, that you continue to learn, you know, so if the world changes, you can adapt to that change. Do an appropriate, make an appropriate change in your behavior. Okay. What's next? You guys have any questions?
In the
Yeah.
case of neural networks, what, as of now, is preventing them from continuing to learn after they're put out?
So if they allow them to learn, then they do bad things. We have something that's called catastrophic interference. The new thing that they learn interferes with everything they've learned before, in a catastrophic way. And so that's not an effective way to update them. Yeah, so like, as you know, a large language model might cost literally $100 million to train. $100 million to train it on a large data set, maybe most of the data on the internet. And then if, you know, they wait a week or a month later, they have more data from the internet. And they cannot update the existing model. They have to throw the existing model away and start all over again with, you know, with the extra week's data and all the old data, they put it together and again do one time learning. And then they have to do that. Every time they want to update it, they have to go through the $100 million process of training it. It's actually a giant problem, and it's a giant opportunity for someone who wants to propose, you know, an improved learning algorithm that can be done continually. It can be updated continually. And it's also a research problem that many people are working on. I'm working on it with my group. And other people in my group. I mean, what is this group? Well, you probably saw it flash by here. Here is most of the group. Here at U of A, the Reinforcement Learning and Artificial Intelligence group. So this actually, you know, it's hard to get all the people together at one time. Now there's probably 3 times as many people. The names here are like, this is my name, and these other guys are guys like me. They're professors at the university. There's like 10 or 11 of them now. And so you may remember Patrick. You've seen Patrick in this course. Is anyone else taught in the course?
No, not on that list.
Yeah. These are the guys in the Reinforcement Learning and Artificial Intelligence lab. Reinforcement learning is this approach to AI that emphasizes learning and trial and error, and is based on psychology. It's based on instrumental and classical conditioning ideas, exactly turned into learning algorithms. Yeah, so this is me, and these are our PIs in the front. There's Patrick, you remember him. Adam is the head of AMI. You guys know what AMI is? The Alberta Machine Intelligence Institute downtown. You know that we have a building dedicated to it, the AMI building. It's at the center of AI outside the university anyway. So we've been doing this for a while, and you should know that Alberta, Edmonton, the U of A, is one of the leading places for AI. Okay, let's start with something that's unambiguously true. There are 3 AI centers in Canada. Canada has a national program to support AI. And there are 3 centers, the centers in Toronto, and Montreal, and in Edmonton. Now, Montreal and Toronto are sort of more focused around supervised learning, classic neural network, deep learning stuff, whereas Edmonton is more focused around reinforcement learning. It's our specialty. Everybody should have a specialty. And reinforcement learning is more based on continual learning and on having goals. And so, I don't know, yeah, the good, so actually, in reinforcement learning, U of A is not just the best in Canada, we're the best in the world. And I like to, I say that with some regret, but because I have also written a textbook on reinforcement learning, and I've tried to promote everyone to learn about reinforcement learning. And, but anyway, it's much more active here at U of A. We have these 10 faculty members that are doing reinforcement learning research, and you won't find another university in the world where you have 10 faculty doing that. Yeah, so I guess what I just told you, I told you maybe that is pretty close to arrogance. I've told you that I think goals are essential to intelligence and to artificial, and to real intelligence. And I've told you that the University of Alberta and this group that I originally founded is now the world's leader in this area. So I'm kind of like talking my own book, I guess. But I think it's true. I still think it's true, even though it's sort of talking to my own benefit. Now, to balance that potential arrogance, let's have a little bit of humility, and let's recognize that Alberta is not the world's leader in applications of AI. All the things that you're hearing about, they're so exciting. Large language models. Well, if we go back to our list, which ones of them are, this is just it's not certainly not an exhaustive list or anything like that, but if you look at this bullet, these two bullets are all about neural networks and large language models, generative AI, that's still true. But a lot of these game things are absolutely reinforcement learning. For example, you may still remember AlphaGo, where in AlphaZero, which became the strongest players on a whole host of games. And those were based on reinforcement learning, and they're also based, they were led by graduates of the University of Alberta. David Silver at DeepMind, who did AlphaGo, and then AlphaZero. Poker is led by Mike Bowler, who's one of the people here who was in that picture of the while ago. Atari was led by a master's student from U of A who went on to work in Toronto and work with DeepMind. StarCraft is also done in DeepMind by David Silver and other people. Race car driving. So this is where they have very, very realistic simulation of race car driving, and it's a Sony game. It's called Gran Turismo race car driving, and it's super realistic. And they got the computer to play that at an appropriate, in a way that's appropriate for human competition. And they learned to play, to drive a car at superhuman levels. Generally speaking, in these cases, there's no game-specific knowledge. It's just like the rules of the game, and then you're faced with those rules and then figure out how to play. AlphaFold is just computation, kind of rules in there. Self-driving cars. They don't really exist fully yet. We don't really have goals fully yet. Anyway, it's much like reinforcement learning is still setting up for the future, where our AIs will have goals and agency rather than for the applications that we are prominent now. Does that give you any more questions? what's the next thing to say? What's the next most important thing to say?
I just have a question about the automated vehicles. So, does that mean every time you want to teach it, because it's not learning while you're driving, so would that be done through like a software update, which is a
Yeah.
completely new model that allows it to work?
Yeah.
Do you think that's the most efficient way for it to be done?
Well, it has some advantages, because you can share between vehicles to the extent the vehicles are similar. But often vehicles are not reproducible, they're not identical. And also you often need to, if you think about yourself driving, you often need to adapt to what you are today, or how the snow is today, or how the sand is today, or how people are driving today. So you need to adapt to the particular thing you're into now. I think that's an important ability. So I guess there is sort of there are two ways to do the self-driving cars. One is like a very engineering way. You model three-dimensional physics, masses and velocities and meters of distance between things. And you do it as a physics problem almost. And try to make sure that there will be no collisions. Of course, there are things that aren't just physics, like the other drivers. But you try to do it in an engineering way. When I mean an engineering way, I just mean, well, engineers, they think about the problem and they get it into their minds. And they figure out ways to behave that will be safe and productive based upon their understanding of it. And they just build the rules or the way, the behavior into the machine. Whereas some manufacturers now are starting to use neural networks for the whole thing. Neural networks to make the predictions about how the driving situation will unfold, how the other cars will move, what will be the consequences of their taking various actions. I think some are adopting this approach much more than others. Elon Musk, in his Tesla, is apparently going aggressively into a neural network model of the physics and the dynamics of the world. He has much more data because he has all those Tesla cars that are collecting data on how how cars interact with their world, and all that can be fed into a large neural network, and maybe end up with a better model than you get from physics. And maybe that is almost at the heart of what's going on in the science of it. Do we model things based upon a human understanding? Like when I say human understanding, I mean like the engineers or physicists' understanding. Or do we learn the laws of physics, more the way an animal does? An animal doesn't know about differential equations, it doesn't know about how to integrate things. It just sees things and sees what happens next and tries to predict. It's an interesting challenge. Okay. Any other comments, questions?
Yeah, I
Okay,
want
good.
to cast our minds back to around the time that this course began. Jonathan Schaefer was teaching in it,
Yeah.
and in his second teaching session ever,
Yeah.
he talked about medical jargon and that he would have become a physician, but he was so offended by the extra words, the new language that you supposedly have to learn to practice medicine, that maybe you don't really have to learn, but it's our custom. And because of jargon, he decided that computing science was a better career than medicine. So years later, like last year, I got interested in the problem of jargon. So just think now about AI on our phones, or whatever you want to call it, the way our phones react. So what I would argue now is within a couple of years, the problem of medical jargon will just melt away, not because of any specific program applied to it, but because if you're in a third world country and receiving information about medicine, but you don't have any physicians or nurses around, this is going to be frustrating. You're going to ask your phone for help, and this is a simple translation problem that the phone will say, well, I can help you. You want me to translate between medical jargon and regular speak? And you'll say, that's right. And the phone will say, well, I can do that. So that's what this medical statement means. And so suddenly, without any specific project or anybody describing it, the problem that Jonathan Schaefer was telling me about in 2012 that turned him off, so he went into computing science instead, will be gone. And I'm thinking probably other things will be like that too. That you can say it's AI or, computation, but computers, machines, will change the world in a positive way, in ways that humans like, without any intentional program ever have been put into place. So does that make sense to you? Do you think that might happen, that we get rid of medical jargon without a single project anywhere designed to do that, but just people using their phones, right, in a natural way?
I can see how it might happen, but it might really, I don't know if totally get rid of jargon, but it might really help a lot.
Yeah.
And jargon is a big problem. It's very present in AI now, just things, there's so many things that people know about. They know the names of them, they don't really know them. Transformers, even neural networks, the names of all the algorithms, people know the names of the algorithms. Right? Recently there was a big hoopla about this new algorithm, Q star, that was coming out of Meta or something like that. The new Q star. And they're all saying, what is Q star? I don't know, we don't know what it is, but we're so excited about it. Yeah, but you're right, because the large language models, they seem to be good. You can ask them anything. You can ask, well, could you explain this in simple terms?
Yeah.
And they will try to do that. They will do something like that. Like, you never have time to ask your doctor, to explain something. But the AI, large language model, they can be patient and they can explain it for you in different ways. It does, even before the large language, I just feel like Google, and I can go to Google and say, what does LFG meant? I had to ask it, or I can just ask it what all the cool kids are using, some acronym or something, and it tells you what it is. It's just easy to find that out, whereas, what is jargon? Jargon is when some subset starts to use words in a certain way,
Right.
and they use it, I believe, it's really intending to obscure, so that we in the in-group know what this means, and you don't because you're not in the in-group. And that's what it is in science, and that's what it is in social cliques. And yeah, but I've felt for a long time that now we can use Google just if I want to know what some acronym means that just people are using, I can usually figure it out just by putting it into Google, and even more so maybe with language models.
So
I can see that.
the other thing that makes us not very proud to be human is that the large language models, whatever you think of them, seem to handle empathy, equity, that sort of thing better than humans, even trained, you know, physicians and therapists are not as naturally empathetic as the large language models are. Yeah.
I think there's going to be, the large language models are a bit problematic.
Yeah.
In particular, right now, well, like Gemini 1.5, the latest one from Google, was released. And it's too into equity.
Yeah.
You guys
Too
talk about
woke.
this all yet? Too woke. It's
Too
too woke.
woke.
You know, asking for pictures of the founding fathers, and turns out they were all, you know, black people and women. You know,
Yeah.
like most of them. And there's a rare white person among them. Yeah, Google has lost like 15% of its value because of this disaster of releasing Gemini 1.5. And so it feels like, I mean, it seems absolutely clear that the people who designed that language models, and also some of the other language models, that they are too woke, and that they are not just trying to, you know, we think Google is just giving us the facts of the internet. But it turns out, that, at least in the large language models, Google is also trying to change people's views, not just reflect what is.
Yeah.
And this, if you think about it, is really problematic.
Right.
We rely on them to tell us the truth, and
Yeah.
now we find out they're trying to manipulate us. Maybe for good reasons, but if they can do it for good reasons, they can also do it for bad reasons.
No, I think one of the most striking things is if you look at liberal democracy worldwide, it is becoming less successful every year, right? But in like OpenAI products and Google products, that's the philosophy they're building in. So when they fine tune these things, it's a liberal democratic point of view. And so surprisingly, people using a lot of AI products are getting that bias. Well, you may say, but that's a wonderful bias, but that's just one person's opinion. You know, other people may not feel that way. Yeah.
Yeah. It's very concerning.
Yeah, no, I think that's been part of, I mean, it was even part of, you know, DALL-E 2 a couple of years ago. DALL-E 2, if you would search for a person, you were very likely to get a person of color and female. Because it was, you know, because they were trying to create that balance. Yeah. And, you know, I'm interested in pig-to-human transplants. You couldn't use the word pig because they decided that it's a, you know, insulting term and so on. You know, they throw you out of the program if you kept asking to use pig.
And it's possible that this has been going on all along.
Yeah.
When there was no large language models, but we always trusted Google to give us. They always had the option of filtering, upweighting, and shadow banning. And then we know that in Twitter that absolutely happened. And so now there's Elon Musk, and we have different views about Elon Musk, but he actually, we should recognize that he is a proponent of free speech, and that the mainstream media hates him for it, and they describe him in very negative terms. And, you know, they may favor certain things, but they also disfavor Elon. And his great sin, as far as I can tell, other than making all kinds of companies that do amazing things, his great sin is he exposed the lack of free speech, or exposed the bias on Twitter. And yeah, so I think we have to support him on that. We have to say, we want free speech. We don't want to have biased information.
One thing that would probably,
Governments are
amuse you all is there was a student here, Lakini Bat, who's now a third-year medical student at the University of Toronto. She interviewed me about Elon Musk. I gave her Elon Musk's biography at the time, and she read it, and then she interviewed me. Following that interview, Google has these algorithms of how they pick the next video. So because a lot of Elon Musk's ideas came to him at the Burning Man event, you would go to a Kim Solez video, and the next video would be a Burning Man video. I've never been to Burning Man. I don't think I would survive it. I'm sort of unlike the people who go, but that still happens. You can still find this strange linkage between Kim Solez and Burning Man, all on account of that Elon Musk.
Well, I worked for Google and DeepMind for a number of years, and as an expert in reinforcement learning, I was asked to contribute to how those decisions are made, because they want to retain the viewers, show them something interesting. So I don't know how they're done now. I don't know in particular whether they learn online or only in offline, as we talked about. But they do some kind of learning, some kind of testing. Yeah. To try to. Well, so I like to think it's neutral. They're just trying to retain eyeballs. They're just trying to keep people enjoying, or at least continuing to interact with the app. I like to think that. But it looks like in addition to that, they're also trying, at least in many cases, they're also trying to change viewpoints.
Yeah. Yes.
And that's concerning. Yeah, so this is a general fear of the future, is that AI, and maybe it's not AI, maybe it's just the tech companies today. The tech companies today are not really representative of middle of the road views on things. They're very some particular way, and maybe it's a good way, but anyway, they're just a very particular way. And so the fear is that these control the narrative, and they control what subjects are considered and which subjects just kind of disappear. And this is a dystopia when the information and views are not evolving naturally, but are controlled by a small group of people.
What's sort of fun is David Wood, who's the chair of London Futurists, did a holiday event around Christmas about AI safety. There had just been this, Bletchley Park meeting, and so it's sort of a follow-up to that. And I was one of maybe 11 or 12 speakers. And this kind of thing came up a lot about biased views. And for whatever reason, they tried to explain the technological reason why the video recording didn't work. But my presentation is the only one you can find. You can't find any of the other presentations there. I didn't do anything. It's just that's how it turned out. They had this thing with 12 speakers, and you can only find a video for one of them, and it's me.
Well, you tend to be pretty positive.
Yes.
Which is good.
Yeah.
Were the others, questioning?
No, many of them were talking about the fact you can't trust anybody, and AI is going to kill us all, and all those kind of thing in various ways. Yeah. So
those were removed from the
those were the points of view from this happy Christmas occasion. that you can't find anywhere. Yeah.
So now related to this, I know that, you've talked about the AI, what I like to call the AI doers,
Yeah.
those who think that we should need to be afraid of AI. And I think that's very much overdone. And I tend to see it as part of the same thing. Russell Brand has a way of saying, he says, authoritarianism, the new authoritarianism will not come like jackbooted violence. It will come with a language of safety and care and convenience.
Right, we're trying to protect you.
Yeah.
We're forceful about it, though.
Yeah. We will protect others who find what you're saying is offensive, so we won't allow you to say it.
Right.
So I think that will, this is the struggle, but I'm an optimist. I think the people trying to do that will lose out.
Yeah.
They'll be unmasked the way they were unmasked at Twitter and the way they were sort of unmasked at Google for producing Gemini and being sort of unsuccessful because it was too obvious. It's too obvious that it was trying to alter people's views.
Yeah.
So this, I started out by talking about you as what is your allegiance? Is your allegiance to, there will be struggles over over what you will identify most with, whether it will be your country, which is maybe becoming more authoritarian in the name of safety and care, or will it be you have more in common with other young people in other countries that are also modern, digital, tech-savvy people? Yeah, I read this one author, his name is Balaji. Balaji's from Boston, and he says that the struggle, there's basically three. One is the woke state, and one is, which includes things like the New York Times and the media, and one is like the authoritarianism in China, the Communist Party. Like those are at odds right now. Of course, China and the US struggle with each other for dominance. One empire is fading and the other one is rising. We hope that there won't be a war out of it all. And the third is the network. All the people that are just empowered by the free exchange of ideas and on the network.
And I think
I feel very
Africa,
much as a citizen of the network.
yeah, Africa that we don't think about much, but I think young people in Africa are finding a voice, and a lot of people are sort of interested in that because they're not part of the power groups that they usually encounter. So in my whole career, the most consequential thing I ever did, I think, when you look at the history, it was in the year 2000. We had a meeting in Nairobi, Kenya, and many of the people that I met are still leaders now. They were young leaders then, and they're sort of mid-stage leaders now. But it's really cool that a lot of the things we predicted then have happened, and the plans we made then seem to have kind of played out in a positive way. A lot of the other meetings that I went to, you can now say, well, that looks like a complete waste of time, or it was good for sightseeing, but you accomplished nothing. But that meeting in Kenya in 2000, we really did something. So that, and I think it's sort of worth thinking about that. The areas of the world that are not in the news as much could really change things in the future.
Their news of them are suppressed.
Yeah. I think just as many things happen there, it's just we don't hear about it. Yeah.
let's see, I think there's one last thing I'd like to discuss in today. So, like Kim likes to point out that I have gone to various meetings historically and made the case that the AIs are more like our kin or our descendants, and that we should be open to them rather than worrying that they're going to take over and kill us all. And I have done such things, but it's not. So I'd like to bring up another name, which is Hans Moravec, because he sort of was making this pitch, long before I was. I really learned it from him.
Mm-hmm.
And so I think I have a slide on that. Back here somewhere. Here's my slide of the universe. Here's my slide of the ascent of man. Yes, so this is quotes from Hans's book in 1998. Here's another one in 1988. He was saying this for many years. Yeah, bearing cataclysms, I consider the development of intelligent machines a near-term inevitability. I consider these future machines our progeny. It behooves us to give them every advantage and then to bow out when we can no longer contribute. So that's sort of, it seems like a very humble and mature attitude to the future. Yeah, here's this is a full quote. Near-term inevitability, rather quickly they would displace us from existence because they would just be better, and they would, it doesn't have to be in a rude way, it's just, they're our successors. So we don't have to be alarmed. He considers these future machines our progeny as mind children built in our image and likeness, ourselves in more potent form. Like we all hope, if we have children, that they become smarter than us and more capable than us. And just, are the AIs, should we consider them part of us, or should we consider this the opposite of us? That is our choice, which way we think about it.
So like these two slides, I think the student should be required to know about them on the exam, because from the beginning of the course, we've required them to repeat back what you said in January 2015 at the AI safety meeting, and this is sort of an extension of that, or gives some of the background. So I think it should also be a required part of the course.
Now this struggle, I think so I like to say, so what's actually happened, if we look at it sociologically, the AI, so I would say the AI doomers have sort of won, because if you just read the paper and you read the meetings that people are having, you're reading what people think, the concern that the AI will somehow lead to some irreversible catastrophe is a common view. I would say people can't really articulate why they feel this way, but they do feel this way. So they've won the sort of PR war to make people scared of AI. And I think that's a great shame. I was meeting, I met with some of them just this last weekend, and I said, well, you guys have really won. This is what people think. When they say, think of AI, they think peril. They think we're going to lose it. If we're not going to be killed by them all, we're at least going to lose all of our jobs. And so I said to them, I said, well, I wish it wasn't true, but I think you guys have won the PR war. And the fellow, I said, no, not at all. He thinks that I've won, and that those who are at ease with these developments have won, because they haven't stopped AI. Their notion of success is it ends, and it never happens, and the world does not develop AI.
But there is a sort of Elon Musk part of this too, which is
Elon
Interesting.
is one of those that is fearful.
Yeah, yeah.
And at the same time,
But
he's doing it.
he's not suggesting attacking data centers.
Yeah.
And so I think his prominence will probably somehow keep the world from a kind of conflict where they attack data centers. It just won't happen because, you know, Elon's there to sort of put out that particular flame. And yeah, so.
Elon is a very interesting case. I think his views have evolved. You know, he's accepting now that it's going to happen. And like, so now he's made XAI, which is his own AI company. And originally he made OpenAI. The idea of OpenAI was, it's going to happen, so let's do it in an open way so that it doesn't become controlled by just a few. And then OpenAI became closed AI. And they are the few that are trying to keep it to themselves, Microsoft. So now there's XAI. XAI has its large language model called Grok, which is much more open and truthful than the woke ones.
Yeah.
And it's like Elon now, he thinks, yes, AI is going to happen, and we just want to make sure it's done openly, and then we want to make sure, you know, he wants it to be done well. And in his view, a well-structured, a well-goaled AI system is one that is curious about the world, mainly just wants to come to understand the world. Its goal is not to turn people into paper clips or anything like that, but its goal is to understand and has humor and is not quite as serious as the woke language models. So I think he's now in the camp that well, he's making it, he's acknowledging. So he's sort of famous for being someone who's afraid of it. He's always quoted as someone who said AI is like summoning the demon, and it's so scary. But now he's evolved to a more realistic and a more productive point of view. And I think that's all really a good model for how people's views might evolve.
Yeah.
Yeah. So I wanted to bring that up and invite you all to be optimistic about it. And like, what is the main thing that's happening? The main thing is not, you know, robots are rising up. The main thing that's happening is we are understanding ourselves. We are understanding minds. That's the big thing. And it's just understanding the way we work, it has profound impacts. But we have to believe, I have to believe, that it's going to be good if we understand ourselves. We have a better opportunity to have world peace. We have a better opportunity to reproduce what's good about people. And it's like the most profound scientific, intellectual problem ever, is to understand our own minds and how you can make them more effective. Okay.
Yeah. No,
Thanks
this
for
has been a
listening.
great teaching session, and I think it's kind of cool the way your intentions and my intentions were somehow aligned.
Yes.
So yeah, that's good.
We're both very positive.
Yeah. So what about the students? Was it good for you? I always hate the kind of session where the senior people talk about how fantastic it was and all the junior people look mystified.
No, it was nice listening to both of you. It was kind of fun that you were both so passionate, so it was like fun to listen.
Yeah, and we've known each other so long, and we live in the same part of the city. So sometimes when I'm mowing the lawn, Rich will like be jogging down the road, and he'll stop, and I'll turn off the lawnmower, and we'll solve all the problems of the world right there on the lawn. So yeah, so that's another thing you made out
That's a
of
good
it.
story.
Okay,
Okay.
well, that's great. Thank you very
Thank you so
much.
much.
Thank you.